Today we're going to look at some math terms, some basic math terms. This is a polynomial. This is a three-term polynomial. Each one of these parts of the polynomial, that, the negative 7x minus 7x, and plus 2, these are all called terms. This is a term of the polynomial. And these two terms, 3x squared and 7x, are called, negative 7x, are called variable terms, and plus 2 is called the constant term. Like terms are when two terms have the same exponent and the same variable. Like, for instance, none of these are like terms. 3x squared, 7x, they have the same variable, x, but this is squared and this is single. But if I had something like this, 5x squared, or 3x squared and 5x squared and negative 2x squared, those are all like terms. Like terms. Because they have the same variable, x, and the same exponent, squared. I can add like terms together. So say if I have 3x squared plus 5x squared, I think to myself, well, 3x squareds plus 5x squareds, that's 8x squareds. Or you could have factored out the x squared and like bring that to the 3 plus 5 with the x squared on the outside, gets you again 8x squared, or 5x squared minus 2x squared. 5x squareds minus 2x squareds is 3x squareds. It's just like saying 5 hamburgers minus 2 hamburgers is 3 hamburgers. You know, it's just the same idea, no different than that. They must be like terms to add or subtract. Otherwise, you can't add or subtract them. Unlike terms can multiply or even divide. For instance, if I took 3x squared times 4, well, because of, that'd be 12x squared, right? Because of the commutative law, I can put them in any order, so I could put them like this first if you wanted to. You could just do this, think about it, 3 times 4. 3x squared times 4 is 12x squared, so 4 times 3x squared is 12x squared. And I could even do other things like 5x times 4x squared would be 20x cubed. Now this brings up an interesting point. How am I getting an x cubed out of here? 5x to the first times x to the second. Well, x to the first times x to the second is the same thing as x times x, because this right here is x to the second, and this right here is x to the first. X times x times x is obviously x to the third. X squared times x to the first is obviously x to the third. Sometimes in an expression, you'll have this distribution. So what you're doing is you're multiplying that 5x times the 3x squared, and then you're multiplying the 5x times the 2x. So I have 5x times 3x squared plus 5x times 2x, or 5 times 3 times x squared plus 5 times 2 times x. So I get 15x cubed plus 10x squared. Now let's talk about these exponent multiplying, and let's develop some rules for exponent multiplying and then apply them to problems. Now let's go back to this easy problem, x to the 5th times x to the 4th. I'll bet you are already seeing, and you're probably already guessing from what we've just done, that that's x to the 9th. And it's easy to see if we expand these factors. X to the 5th is really x times x times x times x times x. And x to the 4th is really x times x times x times x. So count them up, and I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 factors. But x to the 5th plus x to the 4th, what do you think that is? X to the 20th, maybe? Well, no. It's just x to the 5th plus x to the 4th. Can't do it. Why can't you do it? Not like terms. Not like terms. And remember, you have to have like terms in order to add or subtract. So these two things right here can't be added together. It's that interesting. Here's the basic rule. X to the a times x to the b equals x to the a plus b. When the same variable, but with different or the same, just exponents, is multiplied, you add the exponents. When you multiply factors with exponents, you add the exponents, given that the variable is the same. So in other words, if I did this, if I took x to the 3rd times x to the 4th, what do I get? X to the 7th. But if I took x to the 3rd times y to the 4th, I don't get xy to the 7th. No, I don't get that. I just get x to the 3rd, y to the 4th again. That's as far as we can simplify that. What about division? X to the a divided by x to the b. Well, that will be x to the a minus b. This is really easy to see. For instance, if I've got x to the 9th divided by x to the 3rd, well, I've got x, 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 x. I've got 9 factors of x divided by 3 factors of x. These 3 x's will cancel these 3 factors, and look what I've got left. 1, 2, 3, 4, 5, 6. Got x to the 6th. So this must have been x to the 9 minus 3, and that's the basic rule on that. Okay, now let's try a problem here, and you see if you can do it. What do you think this is? X to the 3rd times x squared divided by x to the 4th. What do you think it is? Do you think it's maybe x to the 9th, x to the 1st, x to the 0, x to the 2nd? Which one do you think it is? Well, it's this one right here. Now, let's go back to our order of operations, our PEMDAS. And remember, in our order of operations, we learned that anytime something's more complex than a single number in the numerator than the denominator, there's a parenthesis around it. So here I would have had x to the 3rd times x to the 2nd, and then I divide that by x to the 4th. X to the 3rd times x to the 2nd, according to this rule, would be x to the 5th. Divide that by x to the 4th, then, according to this rule, would be x to the 5 minus 4, or x to the 1st, or if you wish, just plain x. Try these two problems. Stop the video and try these two problems, then come back. Okay, so you're probably ready to go. So I take the constants times each other, since it does say times. I take the variable parts times themselves. So I get, whoop, I did that wrong. I'm getting ahead of myself there. So I get 15x to the 4 plus 20 to the 24th. Here, again, I'm going to separate them out. Now you can do this in your head if you want to. A times a cubed, b squared times b to the 5th. Well, 4 times negative 3 is negative 12. A to the, put a 1 there, a to the first times a to the third, a to the 4th, b to the 7th. Okay, I'll put up some problems for you to try. Okay, try these three problems. These three problems, number 1 here, number 2, and number 3. Go ahead and stop the program and then try them and then come back and check. Let's just do this one here in our heads. 6 times 3, x squared times x to the 4th, and y times y cubed. You should have got this for your answer. This one I did, took the negative coefficients out first. Negative 3 times negative 5. Then I'm doing this part in my head, x to the 4th times x to the 3rd, using this rule, and so forth. Now take that last problem and do it. So just taking this parentheses and working it, I get 12x to the 7th, y to the 4th, and taking this parentheses and working it, 14x to the 3rd, y to the 7th. Put them all together and I get 168x to the 10th, y to the 11th. There's my answer that I get.